sorry for for having this in two parts, but my boss wanted to ask me a question. So this is the one we get here, and then of course we're gonna have our enolate, common attack, carbonyl. These are all equilibrium steps, so I should probably be more careful. Let me number these. I'll draw 1, 2, 3 in the same place. I'm gonna make a 6-membered ring, but we're gonna go 1, 2, 3, 4, 5, 6. On 2, we're gonna have carbonyl, and 6, we're gonna have this. And then the next step is gonna be water, protonate, and the last step is going to be this. That's going to be our product. Okay, for this one, we're going to react 1 and 6. So first we got to make an enol. Then we can have our Cl minus. We'll finish making our enol. Again, I'm choosing to make this enol specifically because I can make a 6-membered ring. Oops, I'm sorry, this is not the next step. I need to protonate this carbonyl first. Again, we're going to make a 6-membered ring. So we're going to start with our first 6-membered ring. This is going to come between 1, 2, 3, 4, 5, 6. So we got to have 1, 2, 3, I guess 4, 5, 6. This is going to be bent kind of like when we did Diels-Alder, but I'm going to not draw it that way because it'll be easier to see this way. We're going to have that right there. Oops, you can't see that that well. Should I lift this out? So you can see that whole thing. Then, of course, we're going to have the Cl minus come in and take this proton. Here, and then from here we need to protonate the alcohol. Then we can have this leave, and I am like running out of space. I'm gonna keep going this way. It's a separate thing, so. Here, we got one more proton there, and we're going to, let's put the structure over here. get to that as our final structure. I think that's the last problem. Oh, no, now we got the synthesis. All right, synthesis of how to get from here to here. So as a general rule, if I'm gonna go from this molecule to that molecule, I'm gonna look and say, hey, this looks like an aldol. I'm adding these 3 carbons under here. So what I'll do first is I'm going to do an aldol, and I'll just use like KOH or something. And then I will get this. I'll just rotate this so that it looks more like the final product. All right, everyone see how that is there. Now, I can use, like H2 and palladium, PDC. And I'm gonna just make this all one color because it'll be easier. And then finally, I can get here in 2 steps, which is KOH, Br2, XS Br2, and then second, having some sort of protonations there. Right, the protonate again, and I'll get there. All right, that was synthesis 1. Synthesis 2, what I want you to notice is that we're adding these 2 carbons onto the molecule. So there's 2 ways I can do this. I can either use an enamine to make this, or I could use LDA to do it. So I'll do it the LDA style, because why not? So if you use LDA, you'll get this, less substituted one, right? Now that I have the less substituted one, I can add methyl bromide or something, any type of leaving group you want, and I'll get this. And I can use LDA again. Still the less substituted, so this is the less, the minor resonance form. Then I can use methyl bromide again. Now the carbon backbone the same, and so from here it's pretty easy. I just need to use like NH3 with some acid catalyst, and I'll make an imine, right? And then I can just use get all the way to the end, and all I have to use is just like a sodium borohydride. Something like that, and I'll get there. Good. Okay, I'm going from this molecule to this one. So this, of course, is an acetal, and you can hydrolyze that off. So let's do a count. 1, 2, 3, 4, 5, 6, 7. And I'm gonna have 7 right here. So I need to get 1 alcohol group here, and I have to have a methyl group. So my thought is, what if I do an aldol? Yeah, let's do an aldol. So I think what I want to do is I want to get this to a dicarbonyl. I'll do an aldol, and I'll get a 7-membered ring, just like this. This is one thing. So if I do H3O plus, I'll get to here, right? Then if I do Jones, I'll get to here. Now I can use like KOH. 1, 2, 3, 4, 5, 6. So let's say I made my enolate right here. That means that 5 is going to be this, and 1's going to be, oops, I'm going to get this as my product. Okay, now let's see. If I'm here, I have the right carbon backbone, but I'm not at the right position. So Oh, okay, yeah, I got this. So now let's just use something like Wolff-Kishner. That'll get me to this. And then if I just use H3O plus, this is the organic 1, right? Protonate, add the OH to the more substitute position, I'll get to there. No rearrangements because you'll be making a tertiary carbocation right there. All right, there we go. All right, now I want to go from this to this. So the first thing I see is I have to cut off a carbon. And so the way I'm going to do that is I'm going to use KOH, Br2, XS. And I'll get to this. Now I can use H3O plus to protonate it. And then SOCl2, because this is like the way you get into any carboxylic acid derivative, is you use SOCl2 to make it acid chloride. And I can just add NH3, and I'll get there. And that's it for this video.